Good morning, good afternoon, or good evening, wherever you are joining us for this edition of Apex Live. Over the next 3 days, I'll be joined by a co-host to bring you the news, interviews, and the latest product introductions from this year's virtual event. Today, I'm delighted to introduce my old friend and colleague, Keith Bryant. Thank you for joining us, Keith. Nice to see you.
Yeah, my pleasure, Trevor.
So, as we all know, that the conference actually started yesterday with the Managers Forum, and there was quite a lot of good debate there. You were involved in the Managers Forum, you took part as well. So let's get some of your takeaways from that. What were the key challenges that you heard of from the Managers Forum?
Well, a lot of it was reaction to COVID, but not only from a negative point of view, from the way that having to deal with COVID had changed the way that people were working. Mm-hmm. You know, words that were used a lot were things like agile, proactive, responsive. You know, a lot of EMS companies changed from their normal business to building ventilators or electronics that's used in patient monitoring and all of these things. I mean, that happened really quickly. I mean, that was not just a US or UK thing. It happened with a lot of companies around the world. And, you know, we have to say thank you to all of those guys as a start, because, you know, it really has made it has made a difference to the way that hopefully we start coming out of this.
Right. I picked up on a lot of that as well. I think the communication was key, and you know, trying to keep the supply chains intact by making sure they were over communicating, if anything, to make sure that there was still the supply of materials, raw materials coming through to the factories.
Yeah, I mean, one thing that was talked about not only in the Managers Forum, but in the events later on in the afternoon and in the keynote, was very much about companies collaborating with other companies who previously had actually been looked on as almost competitors. And, you know, we talk with Industry 4.0 of getting rid of the silo mentality where you keep, you know, everything in together. And, you know, people were starting to work with others. But the thing that I hadn't really picked up on, and I don't know if it's happened very much elsewhere, but was the support that the large OEMs were giving to their supply chain. You know, not necessarily the first tier of supplier, but the supplier to their supplier, who was obviously key to actually, you know, key to the whole thing happening, because, you know, if they went out of business, then, you know, that small part didn't get into the big part and the big part didn't get built.
Right.
And I think that's, you know, that's going to change a lot of people who are looking at just in time, who are looking at lean manufacturing, and they're going to start looking further down the supply chain now.
Right. No, I definitely agree. I think there's definitely a requirement to be able to see inside your supplier's supplier, to get visibility of materials coming through the supply chain, not just take their word for it that you know, they're going to be able to deliver on time. There's also an element of second and third sourcing going on as well, and I think that's been another development as a result of COVID, and partly as a result also of the tail end of the US tariffs with China. Another thing I've noticed as well is the time to market for products is getting shorter. There's a lot of new products coming onto the market with electric vehicles, 5G, all sorts of things. And that's driving a trend towards vertical integration. I noticed, for example, there's a company there, Napratech, recently in California. They were bought out by a private equity company, but the idea is to try and bring in a clean room facility into the EMS factory so that they shorten the supply chain with being able to do advanced packaging and assembly at the same time. And there's quite a few different examples of that happening around the world actually at the moment. So I think supply chain restructuring was another, you know, sort of key topic that was discussed yesterday at the Managers Forum. Any thoughts on that?
Oh, very much. I mean, You know, I asked a couple of the guys who were doing an afternoon presentation whether they thought lean and just-in-time manufacturing and all the other things that we'd done to reduce the number of suppliers and everything else was actually a good thing and or a bad thing, given how COVID had hit us.
Mhm.
And the answer was really, it was both.
Right.
You know, it meant that you had your, let's say your group of key suppliers that you really had to focus on and you really had to work with. You know, it wasn't a matter of, oh, I can dump guy A and go to guy B. You know, they were really starting to forge these partnerships. And, you know, the other thing I think that we've learned, and, you know, it's especially true of the defense contracting business, is that, you know, people are now doing this wonderful thing called working in parallel. You know, the same way that the guys who developed the vaccines were working to shorten well, effectively the time to market or the time to jab the arm. And now the defense contractors are doing a lot of their work in parallel. And the risk management teams in some of the bigger players are also looking much further down the line. And, you know, was listening to a couple of the people who were heavily involved in this. And, you know, they were working on, you know, the pandemic risk way back in, you know, the November before last, before everybody was actually worrying about people having it. And, you know, it shows that you know, let's say that the switched on organizations are able to cope with this. And, you know, God forbid something like this happens again. But, you know, I think a lot of companies will be in a better position next time because of lessons that they've learned now.
Right, that's very true, and I think they did react to it very quickly. But there's also been some other recent issues with supply chain issues, particularly with fabs. Look at the problems we've had in the automotive industry. Now they're kind of newbies to electronics assembly, some of them, and they're not used to ordering the quantities that they need. But essentially, we're in a situation now where the automotive companies are competing with the consumer manufacturers of consumer products for chips, which is not an ideal situation.
No, I mean, the story as I heard it was when this started to kick in, everybody thought, well, nobody's going to be buying anything which is automotive in the near future because everybody's going to be stuck at home. So they switched their manufacturing over to computers, smartphones, all the things that people were starting to order well and above what was expected because of the working at home or the communicating with the office or whatever they needed to do. And, you know, as we all know, once you restructure a fab, it takes a while to get it back again. Plus the fact, you know, for a while now, they've been working flat out to take care of what the consumers have needed, you know, with people moving house and buying new televisions or upgrading the television or, you know, getting every kid a laptop. All of these things have, you know, they've helped certain parts of the industry because, you know, they're going absolutely gangbusters. But, you know, unfortunately, there's a finite amount of work that the fabs can do. And if they're doing A, they're not doing B.
That's true. That's true. Yeah. I mean, it kind of wonders whether there's definitely a requirement for new fab investment in the West, in likes of the United States, and certainly in Europe. I mean, Europe, in fact, one of the news items coming up shortly is, of course, that the Bosch fab came online yesterday and started producing wafers.
Yeah, and I think there's a lot of let's say building before manufacturing happening in Asia also, especially with the China-US thing, where a lot of people are looking to move manufacturing outside of China, and you've got India looking to invest to become a major player in fabrication as well. So yeah, you
really think India's going to, you know, emerge as a big supplier to the rest of the world? Because I mean, they don't have the infrastructure.
Yeah, well, until the last couple of years, I spent a lot of time over there. And, you know, the stories that you heard from some people were woeful. But if you look at now the number of smartphones that India is producing, for its own use and also for export, you know, it's starting to wake up to the fact of what it needs. So yeah, I think, you know, given the time it takes to put a wafer fab plant up and equip it and get it started, I think, you know, the infrastructure is going to happen, to use one of the buzz phrases, in parallel.
Right, right. Well, that would be interesting to see. But I think you know, what we'll hear a little bit about it shortly. But I think one of the key areas that has benefited from this outsourcing has been Mexico. Mexico, Thailand, Vietnam, these sorts of areas have all benefited quite a bit in the last 2 years, really.
Oh, hugely. I mean, before the pandemic hit, I mean, all three of those areas were, you know, very busy with new factories, new equipment, training people. Everything was running really well. I mean, you know, Mexico has a bit of a head start in a lot of ways, but you know, Thailand's a close second, and you know, Vietnam is coming up really, really fast now.
Right. So anyway, John Mitchell made his keynote speech yesterday. Keith, you sat through all of John's keynote. What were your takeaways?
A lot of interesting stuff. I mean, he brought in a lot of people from his senior IPC team, and you know, it was interesting to hear about how, you know, they're approaching legislation now with the advent of COVID, and obviously the new team at the top of the US, and the fact that they were saying that, you know, they think from what they're seeing already, things are starting to work a lot more of a friendly fashion, which is, you know, good for everybody and good for the industry. But, you know, they are lobbying heavily to do a lot of stuff within the US. And there was also a short segment from the lady who looks after the IPC, let's say, regulatory interests in Europe. And, you know, there's also a lot of stuff moving in Brussels as well, which is hopefully gonna help the industry going forwards.
It's great to see they've got a seat at the table now in Brussels,
Yeah.
Which is good. You know, they're getting ahead of the legislation rather than having to inherit it.
Yeah, and you know, it's much easier to, as you say, it's much easier to change it at the beginning than it is once it's cast in stone.
Absolutely.
Yeah.
Okay.
The big.
So anyway, I think it's time that we're going to go and join John's interview. He's coming up after the break. John Mitchell with his keynote. Sorry, my interview with John after his keynote, should I say. It seems like it was just a year ago when we were sitting across from each other at APEX with a pandemic raging in China. What have you learned in the past 12 months as a result of COVID?
Well, so much. First, I think we all imagined that our supply chains were fairly complex, but we really had no real visceral experience with how complex our supply chains really were and how integrated they were. So that's probably been the chief thing that I think that we've learned as an industry out of the pandemic, is just how intricate our supply chains are. And as we have learned that, we've been striving to, overcome any of those challenges that, supply that you've come to rely on and that was always available when you needed it suddenly wasn't. And so I think the industry has adapted very well to that, but it did present a number of
they're very fragile. I mean, especially back in the beginning when everybody was relying on just in time for materials coming from Asia. And of course, when these materials get interrupted because of the problems they were having with COVID, that really started to, send a cascading shockwave across the industry.
Yeah, I know. I remember last year when we spoke, China was experiencing COVID, but really the rest of the world was not so much. And we were talking about how that might impact the design of certain products that, people couldn't go to China to help do that design. Well, that just got multiplied across the globe. So yeah, it was it's been a challenging year, I think, for much of the industry. But at the same time, I feel like the electronics industry really has been the bright spot. We've come to the rescue, and so that just makes me feel really proud to be part of this industry. To say, hey, we helped solve this, moving solutions forward.
Yeah, we definitely did. We certainly stepped up when it came to respiratory systems and all these sorts of things. So how is the to COVID?
Yeah, I think a lot of the industry has talked about being, having Industry 4.0, or as we like to term it, the factory of the future. And there may have been pieces of that, but this pandemic really forced a great realization that there's much more involved in truly having, in terms of having remote access to people, having your customers being able to walk through your factory without ever going in your factory, and building a lot more of that intelligence. So I believe a lot of investment has taken place also, and will continue to take place to really truly get closer to that factory of the future. And another big piece of this that has, I think, brought a lot of awareness is that there are two big challenges that the world faces. One is workforce. We're really trying to we've already have a workforce shortage, and as we bring more and more new technologies into the factory, that pressure is going to get exacerbated. So we need skills training programs, and IPC has been working to develop those kinds of programs so that we can have a very nimble workforce, that when there's a job that you never imagined needs to be done, they have the base skills that they can then grow and be able to do that job. And the other area that I would bring up would probably be on the environmental side. We just, in my keynote that we just finished, announced the launch of our ESG for electronics, environmental, social, and governance, and trying to be a morally responsible, more morally responsible company as you develop your electronics products. The fortunate thing about that is when I've talked to various owners and manufacturers, they're on this already. So this is just going to help them highlight all the good work they have been doing and building over the last few years.
But I guess you could probably expect a bit more environmental legislation coming in with this new Biden administration anyway.
Well, yeah, I think with the Biden administration, but the European, circular economy efforts are strong. And so, we as electronics manufacturers tend to develop things for one world. Nobody wants to build a product that's only good in one region. And so when you have strong legislation that has any aspect to it, whether it's a UL rating or a EU regulation or something like that, we tend to, like ROS or REACH, we tend to build our products to meet all of them, and so we can sell them anywhere.
Right. So, the supply chains, as we talked about earlier, took a beating, from the lack of visibility to shipping restrictions and even more recently the fab shortages for the automotive industry. How can we make these things better?
So that's a big challenge, isn't it? I mean, the better we can be at predicting what our needs are going to be, I think those challenges will be, the people can then build up the capacity that they need to meet those needs. The real challenge, especially on the chip side, is, historically, and our chief economist, Sean Duberback, talks about this a lot. Historically, when there's been a dip in the economy or a recession, tactile goods have typically dropped and so when we hit that recession a little over, or not quite a year ago, around the April timeframe, manufacturers did what they should do based on historical. They kind of backed off and they refocused their fabs in the chips fabs to develop chips for the things that were selling. So you don't expect more expensive goods like cars to be selling. So they shifted efforts to go more toward the electronics market because that was selling like gangbusters, or toward the medical area. And then when the automotive side just did a sharp jump back, it kind of caught everybody unaware, and you can't just turn, there's like an 11-week turnaround for a fab on the silicon side. So that it just caused a lot of delays and angst that people were doing the right thing based on history, and so the way to overcome it is to really try to do a better job of projecting out what your needs will be, and then not living on the just in time. That's kind of been our business has been shifting that direction. I think you'll see a little bit of shift back from that in terms of, hey, we only have enough supply to last 2 days. Well, that's good, but not so good. It depends on what situation.
Absolutely, yeah, because we've got this sad situation, which we've now got the automotive guys competing with the consumer people for chips. So it's not a great situation. Although, admittedly, the Bosch factory came online today and started producing wafers for the first time in Berlin. So there's certainly some light there in Europe. Do you think we're needing more capacity in the United States?
I'm sorry, more capacity in the United
States?
States?
In terms of fab capacity?
Yeah, I think there is an effort to build that. I think you're going to find, because of the pandemic, I think you're going to find more regional capacity desire. So in Europe, in North America, in Asia, you're going to want to make sure that wherever you're building goods, you have a local supply option. It may not be your first choice, but you always have a backup there.
Now, all countries are going to be looking for ways to kickstart their economies coming out of COVID. Does IPC play a role in trying to persuade governments to pass manufacturing incentives?
Sure. We have a strong advocacy effort in DC as well as in Brussels, really working to try to work with policymakers and make sure that the voice of the industry is heard, so that they can, the thing that gets most scary is when you get a policy that is constructed devoid of information from the industry. And so we try to make sure that we're bringing electronics manufacturers to the forefront of that conversation. And fortunately, we're getting good reception. There is a desire by those who are writing policies to listen to those who are building them and try to overcome their challenges, but also as they try to move things in a direction that they would like to go, for instance, on this ESG front, they're listening so that you don't cripple an industry while you're trying to do that.
Right, excellent. Okay, yeah, it was an interesting one that I brought up with Chris earlier today, which was that they just passed legislation here in the UK last week to give manufacturers 130% write-off against all capital equipment sales, which...
Yeah, those kinds of opportunities are very exciting. And the other thing is, industrial policy just needs to be clear. And I think that's one thing that we've been pushing on various administrations to try to help move the, kickstarting the economy again.
So another threat that appears to be a wider threat than we first thought it was is security. We were wrestling with it within IPC from the counterfeit side of it, but it tends to be a lot more nefarious than that, and getting into products that we use on an everyday basis, consumer products. How big an issue is this, and how is it going to play in a digital world going forward?
Yeah, you've hit on it right there, Trevor. As we become more and more digital, this becomes a more and more important issue. And so a lot of our efforts on the Factory of the Future, we have an entire section there that is working on standardization and incorporating security measures into those standards. We have some other trusted supplier security standards already that exist, like the 1791 that is largely used by the U.S. military and those that supply it. So, but it's not just a cybersecurity, if you will. There's also the human aspect of security as well. And so these standards are dealing with all of that. And it's truly a global effort. Some of our board members from Japan actually have been helping lead the way in this for the last year.
Excellent. Or so. Yeah, it's a huge area. And I mean, one of the scary things was, of course, that the recent Roomba situation was a security issue with the LiDAR sensors. Apparently, that was how they managed to get into the system. Which is really quite scary. So final question, John. I mean, how do you think things are going to pan out this week for IPC with your virtual conference? I mean, obviously we would all prefer to be there in person, of course.
So, you know, I find myself moving from virtual meeting to virtual meeting and missing the, you know, the eye contact, the, you know, the shaking of the hands, et cetera, that we normally have, and just seeing everybody's bright and smiling faces. But on the other hand, there are some advantages of doing it this way. So there are a lot of people who, you know, due to travel budgetary restrictions in the past, have never been able to attend an APEX Expo. And this year, we're able to get a lot of people able to watch it virtually. Plus, we've had the ability with certain packages to allow you to have access to it through June 13th. So with that advantage, you know, typically if you're at the show, often if you were just you know, really going at it, you might be able to catch, you know, 3 to 5 sessions a day for, you know, 3 days or so. This way you can get over 100 sessions and have access to it over 90 days. So we feel very positive that it'll be a positive thing, and we're looking forward to some of the survey information coming back to find out whether we should continue offering a virtual portion of APEX going forward as well.
I think it very much will be a hybrid, whatever way these things come back, for sure. But I mean, have you been able to, for example, attract a much wider audience geographically to come and attend the event virtually?
Yeah, geographically, I think it's about the same. It feels fairly similar because we've always had a decent international presence at APEX that we hold in the U.S. But I just have found that it seems like it's deeper into the companies. So a lot of the same companies are coming, but there's different people that are able to join that typically would not have been.
Great. Well, we're looking forward to an exciting week. We've got lots of guests lined up and things to do, so we're certainly looking forward to it, and we wish you best of luck and every success for the rest of the week, and thank you for joining us today.
Very good. Thanks, Trevor. Have a great day.
I'm delighted to be joined by Chris Nash, who's the Senior Product Manager at Indium Corporation. Welcome, Chris. Nice to see you today.
Nice to see you, Trevor.
Yeah. So we're one of the products that you're showing virtually at the event, or you wanted to talk about, is your Durafuse product. That's your low temperature solder. Tell us a little bit about that, and what's the melting temperature range of Durafuse at the moment?
Sure. So, you know, I think Durafuse LT is one of the coolest products on the market right now. Its patented technology is a low melting point alloy solution that's going to provide drop shock performance equal to or better than Stack 305, which is unprecedented for a low temp solder. The melting point or the reflow, I should say, of the alloy system, we like to keep it below 210 degrees C. So it's somewhere between 200 and 210 degrees C. But that optimization of the reflow process is going to be key for increasing and outperforming the SAC 305 alloy from a drop shock performance standpoint.
Right. So I'm guessing the reason that it's performing so well in the drop shock is because it doesn't have bismuth in the alloy. Am I correct?
That's correct. That's correct. Bismuth by nature is very brittle. So we want to do everything that we can to eliminate bismuth for applications that require drop shock performance. Now, obviously, all applications aren't going to require drop shock performance. For instance, TVs, servers, that kind of thing, where they're just going to sit in a room. They're never going to be dropped. If they are dropped, you're most likely going to fracture the screen on a TV, for instance. So the bismuth alloys can be used in those instances, but when you're talking about, say, mobile devices or tablets or PCs. Even PCs get dropped every now and then. Laptops. I can't recall the amount of times I've dropped my laptop while traveling somewhere. So it's important to have the drop shock capabilities with any of those types of handheld devices.
So what's in it? If it doesn't have bismuth, what is the composition of it?
Right. So it's a proprietary blend of primarily a low temp indium tin silver contained material, and then a SAC material, and they're mixed together to create this new proprietary alloy solution.
Okay. Keith, have you got a couple of questions on
it? Yeah, I mean, one of the things that I've been involved in a lot recently is the inert or notness of the flux once it's been through reflow or hand soldering or whatever, because everybody's worried now about Roche tests and all the other stuff. So what's the situation with regards to the residue?
Sure. So low temperature makes the residue reliability important. It's something that's a little more tricky and a little more difficult with low temperature. But we design our materials, our flux residues, to be completely benign after reflow. They pass the standard G-standard SIR testing, the Belcore SIR testing, some of the enhanced SIR testing that the industry is talking about, especially in the automotive realm, where tighter, your voltage is higher. So it's important that we're considering all of that into the design of the materials and the design of the flux and the residue left behind. So with a no clean material, it is truly a no clean material. You don't have to worry about the electrical reliability of the flux residue after reflow.
Right.
Oh, that's certainly good news. And what about testability?
Testability is always a challenge with a no clean flux residue. I think that's more, we see that more with SAC materials. As OSP coatings on boards become more prevalent, I think people are used to leaving, say, an immersion tin or immersion silver or ENIG board unpasted. Now with OSP, you have to paste over the copper OSP. There are some probe technologies out there that say that they can penetrate the OSP, but most times our customers are forced into pasting over. That makes the penetration of the flux residue important to make intimate contact with the solder underneath the flux residue. Now, we designed a number of flux residues to be penetrable by the ICT pin. And usually they're either a soft material, a soft flux residue after reflow, or they are a fast break, fairly brittle type flux residue after reflow. So there's a few different ways to go. The low temp actually makes it a little bit easier because you're not baking the residue and polymerizing the residue as much as you would with a SAC alloy. So it's all really going to depend on the ICT process that's being implemented and being employed at our customer. We can certainly help provide guidance into what might work a little bit best for the application at hand.
Right, that's great. So do you think LTS solders or low temperature solders are going to increase by the number of applications going forward?
I think so. I think we're seeing a kind of a technology inflection point where people are looking at low temp solders for a number of reasons. Temperatures, they have temperature constraints on components, or the PET or flexible substrates that they're using can't go to the 250, 260 degrees C range. I think you have some soldering applications where our builds are becoming three-dimensional and energy costs. although I really haven't seen a study in the industry to say that that's in fact the case. I think that would be a fairly complex study, and it would depend on the energy cost wherever you are. But I really do think that the industry is moving more and more towards low temperature for a number of reasons. It is becoming more prevalent, more important. And Indium Corporation has been involved with low temperature for probably since the entire history of Indium Corporation, starting in 1934.
Right.
Our Indoy #1 is a low temperature indium container.
Yeah.
So we're very familiar with the space.
Yeah, I certainly think if you're not driving your reflow oven as hard, you're bound to be saving energy, somewhere down the line in electricity costs, etc. But anyway, we need to move on because you've got another product we want to talk about, and that's the CW232, a flux cored wire, which you've specifically designed for robotic soldering and laser soldering, that kind of thing. Tell us a bit about that.
Sure. So robotic soldering is becoming more prevalent as well, whether it's for interconnects of connectors in a secondary process, or if it's for an entire board. Instead of hand soldering, robotic soldering is going to be much more beneficial and reliable, and give you the best results possible. Whereas a hand soldering operation, one operator might result in different process techniques than another. So the 232 is really designed for the robotic soldering applications. It's a very, very fast wetting material, the flux core, which allows for fast wetting to the pins so that you can increase the throughput of your process. It also will leave low spatter, which is extremely important from a cosmetic standpoint, but also a electrical reliability standpoint, because you don't want flux going onto gold fingers of the board where you're going to plug it into, say, a motherboard. You really need to be careful with the flux spattering. Now, on the hand soldering side of things, flux spattering is important because the operators tend to get little burns on their hands. So it's important for a safety reason to have a low spattering option as well.
Mm-hmm. Okay. How do you manage to reduce the spatter using this?
Well, it's really all in the formulation, right? So it's a proprietary mix of chemicals to create the flux core that we would put inside of the wire itself. It's really unique. There aren't a lot of solder companies that are really aimed at lowering spatter. I think a lot of people are content with their solder wire formulas, speaking from a competitive standpoint. In Indium Corporation, we're really looking at moving the industry ahead with new materials all the time, new products, bringing them to market and making the industry better as a whole.
So not a lot of margin in the core wire business, so I wouldn't imagine there's a lot of appetite for investing too much R&D dollars into it.
Yeah, that's correct. I would say it's a fairly low margin product, but at the same time, you still have new challenging processes like robotic soldering that are going to need a new product to work properly. It's still important that we're focused on all aspects of the solder industry and investing in the solder industry and our product development so that our customers can benefit. The same goes for wave flux. I think a lot of times wave flux is, 15, 16 years ago when I started in the industry, everyone said that wave flux was going to disappear. Well, it's still here. Selective soldering is still here. Wave flux is still here. We're still aimed at improving our flux chemistries for wave flux and selective solder. So there's a number of materials that we've brought to market recently, and they're really fantastic for helping out with some of the new challenges that the industry is facing.
Keith, have you got any input on this flux core wire, the CW232?
No, I think, Trevor, my only comment is it's nice to hear a company with a holistic approach to the whole of the, let's say, the various processes that are used within the industry, rather than, just going after the,
Low-hanging fruit.
the high return stuff. So yeah, it's good to hear that people are still working on cord wire and wave soldering flux and all those things that through our lifetimes we've heard many times they're going to die.
I think you're right. I think the solder paste is still a primary focus for Indium Corporation. Don't get me wrong there. We have a number of new materials and tried and true materials that the industry is currently using. 8.9 HF, for instance, where it really can't beat it. It's one of the best solder pastes on the market, if not the best. It's kind of the new 92J, if people remember the 92J from the tin lead days. So,
oh yeah,
8.9 HF has been a very successful product for us and will continue to be because it was really developed ahead of its time, we believe.
Right. Well, great. Well, thank you, Chris, for coming in and telling us about both these products today. We wish you every success with it, and we hope you have a good rest of the show at Apex.
Okay, Trevor, thank you very much. Keith, thank you again.
Our pleasure.
How low can you go?
Low temperature solders enable manufacturers to lower reflow profiles, improve quality, and reduce operating costs. Abstracts are invited from leading researchers, industrialists, chemists, and metallurgists. LTS 2021, June 16th. Click below for more details and to submit your abstract.
Yeah, no.
Okay, and welcome back. So, Keith, I mean, it's absolutely true that the wave soldering market and the cord wire market has commoditized quite a bit. So it's nice to see companies actually investing or putting some investment dollars into continuously developing that end of the industry. I'm just wondering how much of it's driven by their desire to come out with new products, or whether it's actually been driven by customer demand for new products in that area.
Well, customer demand for everything on a production line is, faster, cleaner, cheaper, with less faults. So yeah, I suppose you could say that pretty much everything that we touch and everything that we see is customer driven.
Right.
But what I like about some of the larger, let's call them solder companies, is that they're still a one-stop shop. You can get pretty much everything from the bar to the paste from the same place. So if there's a problem, you only have one point of contact to help you with it, or if you want to improve your process or all of those things. You don't have to talk with 5 different distributors and 6 different principals or whatever, and again, this goes back to the stuff that we were saying earlier, about, people are looking at a smart factory, but it's also the supplies that you bring into that factory have also got to be smart.
Right.
So, if you can work with a reactive company who are continually developing new technology to overcome the challenges of the industry, then, probably, dare I say it, you probably don't mind paying a couple of bucks more for some stuff to actually have that support. As an industry, we went through a phase, well, quite a while ago now, where everything had to be cheaper and cheaper and cheaper and cheaper. And, every annual negotiation was, how much money can you knock off this bill? And, I think, people are looking at a more holistic approach now, to use an overused word. And I think they're looking, more at the bigger picture.
Right.
And, I think that helps the whole industry.
Yeah, no, I agree. But it also kind of plays into this topic I was talking about earlier of vertical integration. I think it's more important. especially for chemistry companies and materials companies, to become more vertically integrated to be able to offer the total solution. And a good example of that was the announcement yesterday of DuPont making the acquisition of Laird Chemicals, Laird Performance Chemistry, should I say. That's another way for them to sort of vertically integrate and bring in some of the thermal management materials that are made by Laird into the DuPont portfolio. But then it gives the manufacturer, at the end of the day, it gives you a one-stop shop where you can go for your process solutions, and instead of having 2 or 3 different suppliers.
Yeah, I noticed you didn't mention the $2.3 billion that was the purchase price, Trevor.
No, I didn't. What would you call it? But it's true. It was quite a hefty bill, wasn't it?
Yeah.
But it's certainly synonymous with what's going on in the industry. In fact, we had a couple of other announcements out there over the last 24 hours. I mean, LED division to Smart Global Holdings. That deal was much smaller. It was only $300 million. But it means that Smart will now rebrand into its portfolio. And what that will do is it'll free Cree up to concentrate on its entry into the materials market with the new branding, the company Wolfspeed. And they're going to concentrate on their silicon carbide and gallium nitride solutions, which they're developing for EV and 5G applications. So seeing the integration, getting into the materials market, I think being able to understand materials and how material sets work together going forward is going to be a much bigger component of the industry going forward.
Yeah, I mean, I can understand why Cree made the strategic sale, and it gives them funding to invest in the development of the things that they're doing. But I mean, I'd have said 300 million was quite cheap.
Yeah, I was quite shocked at the price tag on it, but I guess LEDs are cheap. But they had a huge footprint in that business, so it does seem a very low price tag.
Yeah, it certainly does.
Mm-hmm.
I mean,
so there's another announcement which I think you can tell us about from Bosch.
Yeah, right in the middle of the pandemic and all of the difficult times, they've managed to build 300 millimeter fab wafer facility in Germany, and they actually opened it yesterday. It's aimed predominantly for automotive microchips for the EV market. And they say it's going to be fully online by the end of the year.
Wow.
So obviously with a lot of companies, the pandemic hasn't changed their appetite. I also heard somewhere else that Bosch are offering their employees the ability to work from home for 2 days a week long term.
Wow. Well, I think that's a trend that's going to continue across most industries. If you can work from home, then you will have that option. I mean, I think companies have found that people are quite productive when they are at home. For the most part, I think they still need that interaction in the office from time to time. You still need at least a once weekly meeting, etc. But there's definitely going to be a hybrid model going forward.
Yeah, like there will be for lots of things in our industry, I think.
Including this. I mean,
yeah.
Look at trade shows. I mean, we haven't been able to do physical trade shows. This is obviously we're live at the moment, and we're going to be taking a look into some people's demonstration rooms and factories later on during the course of the next 3 days. But it's this is a completely new way of working, and I think when we get back to the physical trade shows, there's going to be a hybrid model there too. I think we'll still be doing this as well as going to physically visit the trade show.
Yeah, I'm on 1 or 2 technical committees for a couple of the major shows, and I mean, even stuff that's happening in November, you know, where I was hoping, got to be honest, I was hoping it was going to be a completely physical exhibition and a conference.
Yeah.
But you know, a lot of the people are saying, you know, it still needs to be a hybrid. You know, maybe we run the event live and then 3 or 4 days later put everything up on the virtual world so people can download it, and the speakers have the option of either standing in front of a probably slightly reduced audience or just sending in the presentation file.
Yeah, I think there's going to be different models for that, and I'm on the same committee as you're referring to. But I think there'll also be a requirement to do it live from the event itself, from the show floor, as it were. But one of the issues there, of course, especially in the United States, is where you've got unionized convention centers, is that the cost of being able to do that is quite prohibitive. But you know, that's just one of the things that are going to have to be overcome. So anyway, getting back to finish off on the topics that you picked up on with John Mitchell's keynote address this morning. What else did you pick up on that seems to be a key aspect?
He did a short segment with Matt Kelly, and that was for me really interesting. They're talking about this Factory of the Future project,
right?
And you know, from listening to some of the other speakers in the management session later in the day, I think they should change the name to Factory for the Future, because I think we can't look at something that's out there. We've got to be starting to work on it today.
Right.
But no, you know, they're doing a lot of work with upskilling, with getting let's say CFX into a larger part of the system. Guys that we spoke that spoke later in the day were talking about, you know, having a quotation model which has the ability to effectively absorb a bill of materials and break it out, and then get pricing from Farnell's or whoever's for all of the component parts, and put it all together very quickly and autonomously. So
interesting. I mean, because there's already a couple of companies doing that.
Yeah.
I mean, in fact, they're one of the biggest growers, or the biggest growth companies during COVID. That's these companies that are doing virtual, pricing. You know that you can put a BOM list in, and it'll tell you if the materials are available, if there's a risk of the materials not being available, and what the real-time price is.
And for me, the real takeaway from a lot of the stuff that I heard yesterday, and you know, when we started talking about CFX, it was machines communicating with each other, allowing data to flow between machines to maybe a central hub, getting rid of a few of the silos, and more importantly, getting rid of the silo mentality. Right. And I mean, I can remember lots of conversations in the early days where people said, oh, you know, machine vendor A is never going to let his machine talk to machine vendor B, because if one's a printer and one's an AOI, all the AOI machine is going to do is make the printer look bad. Right. So we're not going to accept that. And, you know, thankfully, we've moved miles and miles past that now. And, you know, CFX is becoming, you know, to use the computer parlance, it's becoming a higher level language now. And it's starting to incorporate a whole load of things. And, you know, some people you talk to say, you know, Industry 4.0, artificial intelligence, automated manufacturing is going to get rid of 40% of the jobs in the industry. One of the guys that I heard yesterday said it's going to add 1 million new jobs.
Right.
And most of the people doing those jobs are already employed doing something else.
Right.
Because you need to have that mix of ability to analyze the data, but also to be able to fix the problem when you've analyzed the data to find out what the problem is.
Right.
And I think that's something that, you know, Matt Kelly was talking about and a few of the other guys. And, you know, it's kind of been missed out of the equation. You know, a lot of people are worried about change. And as soon as they see, you know, machines are going to talk to each other. We don't need people to do this and we don't need people to do that. What we need is a whole load of people to do stuff. You know, they were talking about a whole load of job names that don't exist at the moment. And, you know, you've seen a few yourselves, like Chief Information Officer and, you know, Data Collection Manager and Processing Manager and a whole load of stuff. So, you know, people need to be reskilled and upskilled.
Yeah, absolutely. No, that's absolutely what's going to happen. And I mean, when I look back, gosh, maybe 12 years at least now, when I went to the first sort of leading edge factory of the future in Germany, that factory had started its journey, believe it or not, 8 years previously. And it had 8 years further on, it had the exact same number of people still working there. They hadn't lost one employee. They had redirected employees and their output was up enormously. They were producing a lot more product, but they had not dropped one employee. They said exactly the same. So I totally agree with you. I think it's not going to be a job killer. It's going to be a job maker, if anything.
Yeah, we just hope that the young people are going to come in and want to do the jobs if they're a little bit more computerish and exciting.
True. Yeah, there's going to be certainly you're going to have more data skills to be able to deal with this going forward, for sure. Talking about some of the new things that have been out there, we have been looking at some of these new products on our Tech Talk Thursday programs every week, and there's a couple of them recently that have been absolutely outstanding. One of them that springs to mind is the Novacentrix machine, but another one was from ASUS. The ASUS has a conference they hold every November called ASUS Technology Days, and generally at that event they roll out all sorts of new technologies, and they bring in some speakers who talk about things that are outside the industry, even just to sort of you know, put a really wide holistic view on it. The big news I saw at this year's Technology Days was the Serio 6000 printer. This new printer works autonomously and basically uses an AGV to load up the stencil, and the stencil then gets automatically loaded into the machine. And it also has an automatic changeover for the stencil cleaner and the paste cartridges. So in other words, it can work 2 to 3 shifts without any sort of human interaction at all. It really was a very interesting program, and we've got an excerpt coming up for you now on the ASUS Serio 6000. Let's take a look. Welcome to Tech Talk Thursday, Season 3, Episode 1. You may recall at the end of Season 2, I did a roundup of all the technologies that we had seen over 2020. Among those was the launch of the Serio 6000 printer by ASUS at the ASUS Technology Days. I'm delighted to say that I have the product manager for the Serio 6000 joining us today, Torsten Wegeland. Welcome, Torsten. Thank you for joining us.
Good morning. Welcome, Jagos. Thank you for the invitation.
Yeah. So I was really excited to see the presentation that you gave at the Technology Days. It looks a superb piece of equipment. And tell us a little bit about the development of the Serio 6000. Was it developed as a concept machine or to meet a specific customer request?
I mean, it's a long story, and I hope we've got enough time. Actually,
give us a reduced version.
It's a long time ago. We already started with smart features that make the life of our operators easier. And we always have to keep in mind customers asking about having people only on the machine working if they are required. And this was more than 4 years ago, the actual start to say, what can we make better? And if you look backwards, and you've been with us all the time, We started with IPEX systems for dispensing. We have done the modular camera unit, so you can quick inter-exchange components in between machines. You can put on grippers, for instance, for a pin placement system. And this was one big step towards this, let me call it, more automated, integrated machine, to say, okay, what is needed, what is time consuming. And this was the intention far in the 2018s. We started with this development, and bits and pieces came to that with predictive paste measurement for reloading paste on the stencil, etc. But in the end, customers still said, we want less involvement of operators. And our biggest problem is that the operator needs to be exactly on the machine when we need to do a changeover, which is, I guess, the biggest task or the most critical task on the operation of a line. And this was the thinking to say, okay, what can we do for the future? And there we started to analyze how the line is working, what needs to be done if you have an order change, if you do a new setup, if you have a continuous run, big orders or small orders. And then we really made like a matrix and figured out, okay, the stencil change, paste change, or squeegee and stencil and stuff like that. And from there, we started. Yeah. We started in the 18s. And yes, to say, actually, it is in customer demand, but no one really said, do it like this. They just said, give us something better.
Right. Yeah, well, it's certainly an interesting development. I think if you put this together with, say, the Fuji NXTR, you've essentially got potentially the beginnings of a lights out factory, or a lights out line at least there. So what functions are performed automatically, and what's the takt time of the stencil changeover?
Right, let's look to probably the takt times. If we look today on the machines, I think they depend on the changeover time, yes, but we are not the bottleneck in the printing process. Normally not. There are other components in the line which are slowing everything down. So the focus was that we have changeovers compatible to today. And if you look, let's start, if we run through the last board and then we know it was the last board we need to do a changeover. Today, you call in your operator, or you have a pulse system today, the operator maybe is on site, and then he starts doing a changeover and he needs about 2-3 minutes, depending how smart he is, how fast he is. Now, with the automatic machine, we know the last board has been delivered, and now APS starts to take the pins away automatically. We can start to swing up our stencil loader. We put the old stencil and the old squeegee in. We take the new one out, and we can do this in a compatible time frame what we have today if an operator is doing it. Now, this could be faster, but there are still some limitations. So we spoke about the stencil loader, which swings up, and we could swing it up much faster, but there are regulations and requirements that you should not exceed a certain millimeter per second velocity, just in case something happened. And we are still limited that you have these limitations. Mm-hmm. Now, you said in another sentence before, lights out manufacturing. Mm-hmm. If there would be no human around, no one you could maybe in some circumstances harm, then you could definitely also move faster.
Yes.
There are limitations.
The Austin American showroom at APEX here. So welcome, gentlemen. Nice to see you.
Nice to see you as well, Trevor. Thanks for having us.
Thank you for having us.
Yeah. So I can see beside you, you've got the latest version of your Aquarose batch cleaner. You've made a few updates to your batch cleaner. So maybe we can talk through a couple of these, starting with the newly designed spray bars. What have you done to the spray bar, and how does it look now?
So we've actually lengthened the spray bar inside the machine. Kind of just show you real quick. And what it is we've actually allowed for better coverage to the corners, and then actually angled our sprays a little bit more to make sure we were getting much better coverage. We've also changed our manifold attachment in here, which is actually going to allow us to retain more of the pressure and basically less fluid loss from the manifold where it attaches.
Right. So have you changed the nozzles, or have you changed I guess, the angle of the holes that are in there?
Yeah, the angles and basically how long the wand is, but no, we're not moving away from our coherent jet technology. We're still sticking with that.
Okay. So you've also improved the size of the heater for quicker cycle time. So tell us a bit about that.
Yeah, that's correct. So we were using a 2 kW heater, but we've actually upgraded that to a heater that's 3 times the size, actual 6 kW. So what that's going to do is when we bring fluid in, it's a much shorter heat up time. And then where it really kind of shines is in drying, because as you guys probably know, in batch cleaners, that's usually the longest portion of the cycle. So by getting a larger heater in there, we can heat it up to temperature quicker and basically evaporate that water off a whole lot quicker.
So what's that done to your cycle times then?
Well, we've actually reduced our drying time by about a third. So we're well below an hour now for a full wash, rinse, and dry.
Okay.
And that's 100% dry.
Right. Keith, you got any questions from it?
No, I mean, that's a significant difference, and must make a lot of difference to your customers. Is it something that you can retrofit, or is it something that's only going to be on the new systems?
That's a great question, Keith. Unfortunately, it's not retrofittable. You know, it could be something maybe that we could do, but it's really very labor intensive, probably not something that could be done in the field. So I would say, it won't be really offered as an option to do on the older machines.
Okay.
Yeah. And cleaning is becoming a bigger and bigger question now, with a lot of people doing conformal coating and people worrying about calf and a whole load of other things. So is that going to make changes or differences to the chemistry that goes inside them? I know it's not really your game, but obviously you have to work with those companies to make sure the stuff doesn't eat your seals and all the rest of the stuff.
Yeah, and that's definitely something, everything we use in our machine is always compatible with the chemistries. The chemistry companies do work very, very well with us. So when they are introducing something new, they'll send us samples as well as, all of their information on it, so that we can make sure that everything is compatible, but generally not an issue. One of the things that we can say that's, really kind of a plus from the chemistry companies is that they, everything they're designing nowadays seems to be working at lower concentrations and lower temperatures, which is obviously going to be better on the machine, but it's better on the environment as well.
So Todd, I believe that you've also updated some of the sensor technology, the digital sensors inside your system. Can you talk to us a little bit about that?
That is correct. So we've actually made a move to a better resistivity sensor. It's the one we use in our higher line preconformal coat cleaner, our Mega Ion. So we just noticed we have much better results and much better accuracy. So what we're able to do during our conductivity monitor and as well as our rose test is actually add that extra decimal into our microsiemen measurement, so that we really are much more precise and can monitor a little bit better. And then we've also changed our pressure sensors in the machine. So basically all of those are digital now versus being kind of an old mechanical style. Same thing with our RTDs for our temperature controllers. All of that is now all digital, much easier to control, much easier to troubleshoot, less connections, things like that. So much more reliable than the old technology.
Well, quite an overhaul of this system, actually, because you've also updated the pumps. So, I mean, there's almost no part of this machine that you haven't updated in the last short while.
Well, and that's true. Now, we actually did stick with the same pumps, but we did add a new pump. So we added a drain pump on the machine as well. And it was something that we were kind of lacking before, at least we thought we were lacking in. And we were just gravity draining. And what we constantly keep hearing is about cycle time. So we really wanted to make all of these improvements to try to increase, increase our productivity and reduce our cycle time. So the drain pump, rather than waiting 2 minutes for a gravity drain, we're able to actually turn that on and drain the machine out very quickly in between cycles.
Right. So just to be sure, I mean, do you use a closed loop system for cleaning?
And that's a great question as well, Trevor. We're kind of founded on EarthSmart technology. We do prefer everything closed loop. So we build this machine closed loop, but we do offer other options as well. If somebody already has their own, DI supply and a drain, we do build it in an open loop system as well.
Okay. So, I mean, obviously, one of the big things at APEX this week is the whole talk about digitization, connectivity, CFX, etc. How well connected is the Aqua Rose?
So the Aqua Rose has always been very well connected. I mean, of course, we data log everything is standard. All the information is there. Plus, we have connectivity through USB or through Ethernet. Whatever the user desires. But what we've added, or what we're currently working on, let me put it that way, it's still kind of in some software development, but we are trying to come out with the first CFX compliant cleaner, and that should be released hopefully by mid-year.
Right. Okay. That'll be interesting.
Yeah.
So I guess, Keith, you had a question about their set. I mean, it's great to see how companies are adapting to the new environment, and you guys have basically created a studio there for customers to come and visit digitally your showroom and actually look at the machine up and close. But before we go into that, you had a question about the set, didn't you, Keith?
Yeah, I mean, it's nice. It looks very professional, but I was going to ask Todd to explain the 2 bottles of alcohol that seem to be quite prominent in the video that he has online.
Well, I think I'll take that one. So this is my first trade show participating with Austin American Technology as I took over as the Director of Business Development. So when you go to a trade show in person, so much of it is really built on building that relationship, having those face-to-face conversations, and maybe you top the night off with a cocktail to secure a nice new relationship with a business partner. We don't have that luxury right now, so it's purely virtual. And we are still working through the kinks of trying to make this virtual trade show as efficient as possible. So Todd and I do tend to spend a lot of hours just sitting here waiting, figuring out what the next step is going to be. So while we polish up the machine, maybe we just need to have a cocktail or two to make sure we get the job done right.
Right. So I thought you used it to toast your clients, once they've made a purchase or something like that. But it's not new actually for cleaning companies to be using whiskey. It looks like a bottle of Jack Daniels there. Is that correct?
That is correct. Yes. Yep. Good eye.
Yeah. Well, I mean, because obviously the chemistry company Kaizen, they've been using Jack Daniels on their booths for a long time because, of course, it's manufactured in Tennessee. Interesting choice. Maybe that's a choice of the cleaning industry.
Well, there is one downfall, I'll have to admit. When you have the Jack Daniels sitting in a booth in your own demo room, the other coworkers want to come around and take a taste, as opposed to having it to attract people to your booth.
Yeah.
So what has the general feedback been then, Todd, from customers for this style of presentation? Instead of being able to come and physically visit the factory or physically visit you at a trade show, what is the feedback you've been getting about this virtual system that you're working with?
Yeah, and I think that's a great question or point maybe to point out. We've all made adjustments and changes throughout, over the past year. One of the things that we first saw was that our demo room that we invested in was so valuable to us when we could have customers come and visit. And then all of a sudden, with a flip of a switch, we no longer have that asset. So we, kind of quickly got together. Of course, with bringing Justin on was part of that as well. But we really decided we wanted to become virtual. So we've invested in the cameras, the microphones, the lights, everything we could possibly do to make a very, very high quality and professional presentation virtually. And what that's actually done for us is we've been able to secure more and more in person or at least via Zoom presentations. And, our closure rate has gone way up, a wonderful asset to us. So regardless of the curveball that COVID threw us, we were able to kind of catch it, I guess, and run with it. And, we've kind of haven't looked back since. We think that the virtual way is going to be kind of the way that things will continue, at least for a while. I don't, nothing's going to replace that face-to-face, but, we're doing the best that we can right now, and actually have been, very successful with it.
Todd, can I just ask you, the closure rate that you have is fantastic. Is it mostly batch machines or inline systems now?
And that's a good question too. To be completely honest with you, our #1 selling machine for 2020 was actually our X30 Stencil Cleaner. And the reason for that was that, or at least that we believe, is that more and more people are trying to get to a more automated process with less employees on the floor. So a fully automatic stencil cleaner that cleans, rinses, and dries with basically a little touch from an operator really kind of made our year. But batch cleaners, inline cleaners, we sold an inline cleaner last week. Batch cleaner, I think we got a PO today right before we started this this call. So we're kind of all over the place. We do offer several solutions. So I really could say that our stencil cleaner was obviously our most popular, but the rest of our equipment was probably an even mix.
And I think a lot of that also has to do with, technology is advancing. I mean, technology has been advancing over the last century at a pretty rapid pace. And we've seen that expedited at an even more rapid pace in the last few years. So even when we talk about the advancements we made here, it's all about the new technology that is coming out, where you can get more done with less. So even upgrading the heater 3 times, you're not actually upgrading exponentially with the amount of energy that you use, which is making these machines much more efficient. So when we talk about our other machines, maybe we run the machine with a pump that's half the size of some of the other technology, but that technology is being outdated as energy efficiency and the overall cost of running the machine is becoming more impactful in the decision process.
Right. Yeah, I can see stencil cleaning, which is automated, being a big attraction to a lot of people, because you get complete consistency of the clean product. And as stencil apertures get smaller and smaller and smaller, then a very clean stencil when you start your production is absolutely key. So yeah, that makes a lot of sense.
Yeah, you're spot on there. And then one of the other main things too is, as Todd mentioned, having less people on the floor. With this new COVID world that we live in, and we'll see how the adjustments happen with the vaccine over the next few years to come. But right now there is a priority on having less people on the floor, more social distancing. And when you can get one stencil cleaner in there that could possibly operate 3 separate lines, you're cutting down on the amount of personnel. We don't want anyone to lose their jobs, and I don't think that's the point we're trying to make. But from a safety standpoint, it allows you to maintain productivity with less people.
Right. Okay. And final question, Todd. I mean, do you think that this model, this demonstration, home demonstration model, is going to be continued once we get back to normal, once we get back to the normal trade show situation? Do you think this is going to be something that you're going to be continuing to do from here on out?
I think the short answer is yes. We definitely, I think companies are looking at it from a point where they don't have to send somebody, they don't have to spend the money, for travel to actually go see a product. But there is also something that I think is lacking from actually watching it go through an inline cleaner and seeing it clean, picking it up and feeling it when it comes out the other end. Right. Doing your own measurements on weight to make sure it's actually dry. Looking at it under a microscope, make sure it's actually clean without anything, any magic behind the scenes. So I think there's still going to be, so people that are going to come, but I kind of feel that it's probably going to be maybe a 50-50 mix of staying virtual and then also possibly some in-person things. I mean, I know for one, I love to travel, and I've been claustrophobic sitting here, I think for a year now. I'm ready to get on the road and go talk to some folks, but I may not represent the general public either.
No, but I think you definitely represent the 2 people that you're talking to this side, Tom.
Well, I think also your question actually brings up a big point. I think this actually predates COVID. I mean, when you look at a lot of the sales processes across all industries, from buying a house to buying a car, even prior to COVID, a lot of those experiences have gone fully online. People are buying houses through, Redfin and Zillow, and people are buying cars through CarMax without even seeing them in person. So I do believe Todd is right when we talk about we'll never get rid of the in-person sales tactics. But I think what this does is it actually allows you to speed up the sales cycle, really get a lot of that investigating done on the different machines you want to consider for purchase, and then meet in person to really finalize that deal. But as far as the investigating and the research process, I think that really is going to be sped up and done virtually.
Yeah, it makes a lot of sense. Well, guys, I want to thank you very much for sharing your showroom with us today. Great to see all the updates that you've managed to do during the last year. And we wish you every success with your system going forward.
Well, thank you so much, Trevor. It's been a pleasure.
Yeah, thank you for your time.
That's great.
Thanks, Keith.
Good. So, Keith, just, as you said earlier, I mean, we both were road warriors before this. We're traveling all over the world all the time. I mean, how have you found it over the last 12 months?
Interesting.
Yeah.
Yeah. I mean, it's like everything. You have to adapt, and you have to survive and do new things. So, everything's gone online. Presentations that I've been giving at conferences have all been either virtual or recorded. Mm-hmm. All the work that I'm doing with clients is all at a distance. Yeah. Some of them are still as they have been for most of the pandemic, pushing me to visit places that unfortunately the current rules don't let us get to. But yeah, it's definitely been different.
But a lot of your work was long haul. I mean, you were doing a lot of work in Asia, and it makes me wonder. A lot of the companies, the manufacturers who used to send people out there to get new products introduced and make sure that the manufacturing is going, the designs are going, being interpreted correctly, etc. A lot of that work is not able to be done anymore. It must have been causing mayhem.
In some areas, yes, it is. In some areas with remote working and remote control occasionally of processes, we're able to debug some of the things that are going wrong, which still leaves me in a situation to be able to be at least of some help. Mm-hmm. But there are 2 or 3 companies who are in the middle of setting up new manufacturing facilities in Thailand and Vietnam, and they've lost 6-9 months.
Right.
Because the engineers can't get out there to install the machines. Once they get a line up, there's nobody there who can work and commission it, and there's nobody like me coming along who can help them debug it and get it fit for purpose.
Right.
So yeah, a lot of time is being lost.
Mm-hmm. Yeah, I mean, a lot of the poorer countries, unfortunately, have suffered the worst in this pandemic in terms of being able to keep their manufacturing going. Places like South Africa or deepest Vietnam, that type of thing. I think they've suffered worse than some of us have here in the West, where we've been able to be a bit more agile and adapt.
Oh, for sure. And it goes back, as we were saying earlier, to infrastructure and strong supply chains, and also to an extent an amount of history. We all have situations where we've been doing it for a long time, and in other areas where it's completely new.
Right. Okay. So one of the things that we've been doing, obviously, during the last year is we have moved our panel discussions online. These were typically panel discussions, as you remember, we used to do at trade shows. And when the trade shows stopped happening, we decided we'd move them online. And it's been good and bad in some ways. The great thing about it is that it's certainly opened them up to a much wider audience. And it's also opened us up to a much wider audience of panelists and experts that we can bring into these panel discussions. So there's been good points and bad points about it, but I think they've been very successful. And we're going to take a look at one now, which was really one we did on dispensing and jetting materials a couple of weeks ago. Just to show you an excerpt, a few minutes of this panel discussion coming up on dispensing and jetting materials in electronics assembly.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.
And let's get moving with our very first question, which I'll give to Sonia, ladies first. What are the primary considerations when dispensing or jetting a new material?
So when you're looking at whether you're going to be just, deciding which pump you're going to be using, which jet you're going to be using, you have to look at the rheology of the fluid that you're dispensing. From there, the viscosity, what dot size requirements you're looking at. And generally that type of information will allow you to choose whether you go the jetting route or the needle dispensing route. For example, if you think about lower viscosity materials, those are usually, they tend to be easier to jet. They offer higher productivity. And basically that would be your solution, your path solution to dispensing those materials. If you're looking at materials that tend to be a little more stringy or they're much higher in viscosity, then you have to really consider other technologies like needle dispensing, whether it's a pump or time pressure of some sort.
Right.
But really, the material itself will give you some, the material itself will give you some tips on which direction you're going to be going to.
Right. Okay. Let's see. Brian, have you got anything to add to that in terms of considerations when you're, choosing what the primary considerations are going to be when you're going to start dispensing or jetting? I mean,
yeah, I think Sonia pretty much hit on it. Viscosity being, one of the main considerations. Viscosity, solids content, the flow rate you need to achieve. How much material you're putting down. Is it? I know today we're mostly talking about miniaturization and micro dispensing, but we still have many applications that are bulk dispensing, like potting compounds. So selecting the correct valve based on the properties of the material and the application requirement are probably the key considerations.
Yeah.
Okay. Okay, that's fine. So I think we more or less covered that. Is there anybody got anything else to add to that particular thing? Is there anything else we should be looking out for? No? Okay, so let's move on. So what are the challenges then for the dispensing of solder paste? It's one thing to dispense an underfill or something that's got high viscosity. But what about a solder paste? You're jetting metals. Let's start with you on that one, Irving.
Yep. So the main challenge that we face during dispensing solder paste are the quality of the solder paste. This is really important. You need to have a reliable solder paste, and you need to be also reliable over different charges. You need to work very close with the suppliers. Another important thing to consider is the mapping of your board. So the dispensing height is quite relevant here. You need to have a very reliable mapping system, a very reliable laser system to map your board. Another thing is, especially if we are talking about the special boards, by special I mean boards with cavities or boards with components, so for rework, you need to consider the proper tooling there. So I would say those are one of the main issues or challenges that we will face.
So when you're saying qualify, make sure you work closely with the solder paste supplier, are you only able to work with solder pastes that have been qualified for your systems?
Yes, correct. So every paste that we recommend, we work very close with the supplier in order to get a perfect fit with for hot valves.
Okay. So Jeff, have you got much to add on that, on the jetting of solder paste? I mean, it's quite a tricky job, really, you know, because you're jetting metal essentially.
Yeah, solder paste is not an easy material to jet. And normally if you use it in standard jets that are contact jets that hit against the hard seat, those will tend to coin and clog over time, especially when you're going to smaller geometries. So solder paste is a very tricky material to jet. I think a couple of things that we take into account when we're jetting at high speed solder paste, rheology is a key component of it. The percentage of the metal loading, the type of the ball size that's being fabricated in solder paste, the dispersion of those balls, any air pockets also will affect the jetting of the solder paste. So I think rheology and working closely with the material vendor, as Irving mentioned, is key for us to fully qualify a jettable solder paste. When it comes to dispensing a solder paste with a needle dispense, there's other factors that we have to take into account. But when you're dispensing with a needle, it's you're not as susceptible to the type of, whether it's no clean or water soluble. When you're jetting, water solubles tend to be more difficult to jet. The metal load up, whether it's leaded or unleaded or non-leaded paste, will also affect the way that you have to select your dispense valve. Usually, for example, an auger valve that's for needle dispensing. There's the dispensing method to choose really depends on the customer application, the throughput requirement, and the type of paste. You cannot jet every solder paste out in the market.
So what type of paste typically would you use? Would it be type 5, type 6 paste?
We usually use type 5, type 6 paste for jetting.
Right, okay.
And sorry, can I mention something?
Yes, of course. Jump in.
Based on experience, if you go for a time pressure or a screw valve, you can also go down to type 4. That should work also for big dots, big applications.
Okay. So it really depends what your the size of the geometries that you're dispensing. Yeah, correct. Yeah. Okay. Sonia, you got anything to add on this? You know, the jetting of solder paste.
Yes, I was thinking when you asked the question, I was thinking issues. You know, what makes it challenging are issues like, you know, flux separation. Sometimes if you don't have the right composure, to Jeff's point, we really have to make sure that we have a good mixture. But some of the issues with dispensing it could be flux separation of the material. If you're going too fast, maybe you have too much fluid pressure. You know, you could also have clogging of the nozzle if you have it sized smaller. So you really have to look at the composition of the paste to determine what size needle diameter you're going to get.
Yeah, most of these pastes come in syringes or tubes, but I mean, is storage of these that paste critical? You know, to avoid getting any kind of separation with the flux in the material.
I would say it definitely has some requirements from the fluid manufacturer to store the paste appropriately. And at the same time, it does require some time to thaw it out, typically more than the typical one component material. So yeah, I believe that does have something to do with it as well.
Right, okay. Anything to add on the solder paste issue before we move on?
Yeah, just regarding separation, I think based on our experience, cartridge pressure is also an important factor to consider. If you put a lot of pressure, the different densities within the cartridge, they're going to be very important. Then the cartridge pressure is a relevant factor for separation.
Right, that's a good point. The cartridge pressure, I guess, has to be even, has to be consistent. Is there a specific pressure that it needs, or I guess that's going to vary, but machine by machine or valve by valve, isn't it?
Yeah, you need to have like a balance.
Yeah, yeah.
Not too much pressure for doing it in order to avoid separation. Low pressure, you will not have enough. You will not have enough material on your dispensing unit.
Okay, okay.
And then
All right.
also,
Sorry.
if I can add, if you're dispensing with an on-off needle dispense valve or an auger type valve where you do not have any constant pressure, then you do see some differences at the beginning of the syringe towards the end. So in these kind of when you're using these kind of methods, when it's not closed loop, it's preferable to have smaller syringes, like a 10 cc syringe, for example, when compared to a 30 cc syringe, because in those cases, you will notice a difference from the beginning of the syringe to the end of the syringe.
When you say a difference between the beginning and the end, what are you talking about? You're talking about there'll be the residue or snap off of the or the tailing of the material, or what are you talking about?
When you don't have any kind of active compensation, the amount of time that it will take for the air pressure to fill the volume of the syringe to be able to push it out, when you're constantly cycling that on and off, will be a pressure drop in your dispensing. So that effectively have less material coming out towards the end of the larger syringes.
Right.
So, when it's a small syringe, it's less sensitive to kind of variation.
Okay, I'm going to move on to my next question. I'll give it to Brian because he's been sitting there nice and peacefully and quietly for a little while. And that is, with decreasing board geometries, should dispensers have linear motors for speed and accuracy versus ball screw? Do you have any thoughts on that?
Certainly, linear motors give higher accuracy, higher speed. But there's much more to dispensing than just the accuracy and speed. You have to close the loop on everything, so there's many more important things like your vision system, so that you can map the board as was talked about earlier with laser height sensing. Map the board as far as any component misalignment or misalignment, skew on the conveyor. You also need to verify the dispense volume, maybe by a weight system built into the dispensing machine to calibrate the dispense volume. So, I mean, just throwing a linear motor into a machine is not going to make it necessarily higher accuracy if you don't have all of these other tools to close the loop and give the machine more intelligence.
But I understand that. But I mean, presumably as we get to smaller geometries and people are looking for tighter accuracy, is it going to be necessary to use linear motors to get that accuracy as part of the mix going forward?
Yeah, I believe so. We've already moved into linear motors ourselves, and the accuracy drops from 20, 30, 40 micron down to single digits. So, I mean, definitely you get more accuracy. And then, of course, the speed is 3-4 times higher.
Mm-hmm. Good. Okay. Irving, you got anything to add to that on the question of linear motors? Does anybody get anything different to say on that or additional to say on the topic of?
Well, I think Brian already summarized it quite well. It's those things are for high accuracy, high dynamic, and especially if we are moving to 200, 150 microns pads, is with really fast environments. I think it's a must for the machines to have linear motors. And just one point: the linear motors they're very reliable on these days. If you put a linear motor in a machine, this machine is going to run at least 10 years. So it's also reliable, and over the long term, it's I think it's a must. Yeah.
Good.
Well, I'd like to add to both what Brian and Irvin said. I think the selection or the requirement of linear motors really is application dependent. There are a lot of applications that are flow rate defined, which means that if you're doing some kind of potting or gasketing, or if you're doing some kind of fine assemblies or sealing applications that are defined by the flow rate of the material, whether you have a linear motor or a ball screw motor, will not improve the throughput of your machine, not improve the throughput of the process. But if you have, for example, a large area random dot application where you need to jet, and you have to jet precisely small amounts, then those type of applications, linear motors are required for the speed and the accuracy because you have longer point-to-point motion. In those cases, I think the application also helps define what's the best machine. because sometimes a linear motor, even though they're extremely reliable, are higher cost. So it could be a little bit more of overkill for industrial assembly, for example. But if you're going to semiconductor where you need the speed and you need the accuracy, then linear motors are par of course, right? You need those machines. So I think when we take this topic of linear motors versus ball screw, for example, the selection depends on the application. And if the application is flow rate dependent, then it could be either or.
I want to thank you all for joining us. Jeff Leal from Micronic, Irving Rodriguez from Semtech, Brian Sturm from ANDA, and Sonia Aldridge from Nordson Asimtech. Thank you very much for joining us, and thank you for watching today.
Okay, so that's an excerpt just from the panel discussion, dispensing and jetting materials in electronics assembly. If you want to watch the full panel discussion, you can, of course, see it on the website at globalsmt.net. You will have to register, of course, before you see it, but the full discussion is there, and there's a lot of good content in there. So Keith, the dispensing industry, I mean, it's growing by application. There's a lot more advanced packaging going into in small packages going into board assemblies. It's very much a growing area.
Yeah, it's growing in different sections. I mean, you've got the ultra fast jet dispensers that are pretty much in some ways competing with stencil printing, or at least competing with the tack time of the line, giving people flexibility because they can make changes on the fly to the, well, I was going to say to the stencil, but effectively to the dispensing pattern of the material. So they don't have to wait for a new stencil to arrive. They can do prototypes, they can do new product introductions very, very quickly and very, very flexibly. And I don't think it competes with the stencil printers. The stencil printers are still going to be there for mainline volume production, but it just adds something extra. And then you've got the dispensing part of it, which I would describe as the slower putting on of the solder paste. And that's either where you've got an AOI system that says, yeah, there's a bit missing off the corner of this pad, so we don't wash the board off anymore, we just dispense a little bit of paste onto it. And then you've got people looking at dispensing as an alternative to step stencils, where they've got a lot of fine pitch components and then some heavy duty, maybe power stuff as well, where they need to be putting down a lot more paste. And then of course we've got pin in hole or pin in paste as well. So the industry is really looking at putting solder paste down in lots of different ways, and the solder paste manufacturers are developing products specifically for those various uses, which fit very well with the let's call it the standard production paste.
Right.
So yeah, a lot's been happening over the years, and yeah, it's helping manufacturing generally, and it's helping first pass yield, and it's giving flexibility, and it's overcoming a lot of issues.
I think that's true. I think that a lot of people have said that printing is where 60 to 70% of your defects emanate from, and a lot of these defects happen to be paste related. So a lot of companies are now putting a dispenser behind a stencil printer so it can do the repair file or the top up of some of these pads or incomplete paste deposits. So that seems to be quite a popular combination. The thing you get, of course, from the jetting side is you get the volume, so the Z height can be higher on the paste deposit. So I think it's complementary in many ways to the stencil printer. The stencil printer, as you rightly say, is always going to be there for the volume deposits or systems, because you know, trying to put 2 or 3 dispensers in place, jetters in place, is in tandem is pretty expensive, you know.
Oh yeah, and also takes up a lot of floor space, which is the other thing a lot of companies don't have. You know?
Yeah.
But you know, you're exactly right. You know, when you know, and again, you talk to 5 experts, you'll get 6 opinions, but somewhere between 50 and 70% of faults that are found end of line happen at the very beginning, which is kind of crazy because the whole line is adding cost. And then you get to the end and you have to do expensive rework with a lot of aerospace and military applications. You can only do rework on certain components and then maybe only 1 retouch per board and all of these things. So you can end up, you know, scrapping a huge amount of value. And yeah, you've just got to, you know, you've just got to correct the paste. I mean, the modern 3D AOI systems are really tremendous compared to the stuff that we started with in the early days, where, you know, there was a 2D scan, and yeah, you just hope the color that you were looking at was solder paste.
Right.
And you know, things have come on really dramatically now, and you know, with the CFX and the, you know, the machine integration and AI and all the, you know, the linking in that we can have. I mean, you know, we're going to be up to some, we're up to some potential amazing first pass yield numbers in the next year or 2.
Absolutely, absolutely. But you know, that's always been a misnomer in the industry. You know, people say, well, what's your first pass yield? And you know, the production manager says, well, you know, we're doing 98.6% or something like that. And somebody says, well, that's a really high number. You know, we're doing really well. But the real problem in the factory is you've got more than 50% machine downtime. So if you could actually increase the machine uptime, you'd actually be, you know, a lot more profitable.
Yeah, and you know, it's one of those things. If you're making, you know, I always have this view that the perfect circuit board doesn't exist. But if you're only making one and you've got an unlimited amount of time to do it, you can do a pretty good job.
Yeah.
But in real life, yeah, there are always trades, there are always balances. But I think the variables are being shut down now. You know, with people using solder paste cartridges to load stencils, enclosed printing heads, you know, even environmentally controlled printing systems. And, you know, also the stuff like the in situ wear, where you can do a very quick paste test that tells you a whole load of information. And, you know, you can use one of those systems on 3 or 4 of your production lines, and you get a feel for how the paste is behaving. Because, you know, we all know over time, paste drying out, you know, volatiles being squeezed out of the pastes, all of these things have an effect on, you know, well, first pass yield, end of production yield, whatever you'd like to call it. And, you know, the more things that we have to control it, and, you know, let's say the more sensors we have that create more data, especially at the front end of the process, means that, you know, everything running through the rest of it is going to be that much better.
Right.
And it's, you know, it's that much slicker, and rework and repair, you know, these are the things that, you know, that kill the profit.
Yeah, some of the new technologies and new systems that are coming out at the moment are just astounding, quite frankly. I mean, there's some really fantastic technology coming down the pipe that is going to revolutionize electronics manufacturing. And in fact, we're going to be demonstrating a lot of it at our eSmart Factory conference, which is going to be at the end of September. We don't know whether it's going to be physical or hybrid or digital at this point. I think it's looking like it's probably going to be the latter. But, you know, we're going to be certainly highlighting and featuring a lot of the new technologies at that event.
Where are you holding it?
Well, we're going to keep that under wraps for another week or so, but we're planning it. Certainly, if it's going to be virtual, you're going to be holding it here.
Yeah. No, I mean, my reason for asking is that, you know, with the vaccine now, especially in, you know, some areas of Europe, UK being one of them, you know, things are opening up.
Yeah.
you know, I heard something interesting yesterday. I have a company that I work with that are setting up a facility in Thailand, and Thailand have now, the government have issued a statement that you can do your 14-day quarantine on a yacht.
Really?
Yeah, or a golf course.
Provided you can afford to stay on the yacht.
Yeah, that's right. You know, providing you can afford to stay at a golf course, hotel, or a yacht, then, you know, you can at least have some comfort in your 14 days of quarantine. But
right.
I'm also hearing that by October, they'll have lifted the bans completely, given the fact that if you have 2 jabs and you do a lateral flow test on arrival, that they'll take away the need for quarantine.
Yeah,
and
I think there's going to be COVID passports. I think that's inevitable.
Yep.
Going forward. Just to circle back on some of the things we were talking about earlier today, there was a couple of more points that you wanted to make on John Mitchell's keynote. What particularly did you want to highlight there?
Oh, so much. I love the comment from Dan Feinberg. I mean, anybody that doesn't know the name, please Google it, because he's one of the godfathers of our industry. He goes back even longer than Gene Wiener, who was actually hosting the management session, and he was talking about, you know, the early days of assembly, which was actually pre-printed circuit boards. Right. You know, where everything was put on frames and hardwired and hand soldered, and the wires weren't even pre-cut. Right. And then he said, you know, you look at how fast things are moving today, and you know, he mentioned printed electronics, battery technology, graphene, a load of more stuff. But one of the things which seems to be, I would describe it at the moment as bubbling under. I know you have a plan tomorrow to talk about it, but it's the photonic soldering.
Yes.
And you've done quite a bit of research and have quite a bit of knowledge about it. So, you know, perhaps you can tell me a bit more.
Well, it's a phenomenal new technology, which is using pulsed lamps, basically very high-powered pulsed lamps that can actually reflow SAC 305 in milliseconds. And it does this through pulsing these lamps, which apply a very extreme amount of heat to the solder joints, and it does it using the patterns. So the color of the substrate is very important, so that it only applies the heat to the right parts. But it does it in milliseconds, so the surrounding area and components can't get hot enough to be damaged. You know. So it really is phenomenal. So we've looked at the tensile strength, doesn't seem to get affected. The quality of the joint is excellent. The beauty of the system is that it takes up a fraction of the footprint that a reflow oven would take. So it's really quite an amazing piece of equipment. And I think the most revolutionary part about it all is it turns the reflow oven, which has always been the determinant of the speed of the line, it turns it from being the slowest machine on the line to the fastest machine on the line. So when you think about all the upstream equipment, the pick and place, the printers, etc., it really puts them under pressure, and you know, potentially can put the throughput on the line up, you know, enormously.
Yeah, and as I understand it, this is let's say new technology for us, but it's an existing technology in other industries. So it's not like something brand new and untried.
Correct. It's been used for years in the roll-to-roll flexible circuit business for doing things like LEDs and that sort of thing. So that's using, you know, different substrates, of course, but you know, the most recent technology jump has been to do it on FR4 and normal substrates that we would use in PCB assembly. So we'll be showing some images on that tomorrow. That's definitely one to look at. Anything else on John's keynote before we move to the afternoon session?
Right. Okay. not actually from John, but a bit of advice from Gene Wiener was to actually start using more young people for the new technology solutions. You know, we have this view, and you know, I've taken a few groups of young people around electronics factories, and you know, the amazing comment is it's not really a factory, because they associate factories with heavy industry and all the other things, and you know, we have this nice clean environment where people are sitting down and doing stuff on computers and loading machines and all of this. And you know, I think you know that's a big perception gap that we've got to get over.
Yeah.
Because you know, regardless of, you know, we talk about reskilling people, but you know, one of the things was that, you know, we need new blood coming into this industry. You know, there are some people who are doing this. There, you know, the IPC is fighting for funding for apprenticeships pretty much globally. You know, we're lucky in the UK because we have the MTC, Manufacturing Technology Centre, up in Coventry, and they're bringing in hundreds of apprentices every year. A lot of those coming in for electronics. They have a full working production line up there and a whole load of other things. In fact, I think they're becoming a CFX demonstration center. So
they are.
That's
They're doing a lot of
maybe
work
going to help with the digitization.
Yeah. Yeah, no, they are. They're actually contributing quite a bit to the Factory of the Future initiative that has been talked about at the show. So that's interesting. We're hoping to maybe catch up with them on Thursday. So what about the afternoon session? What did you pick up on that?
The first two guys on in the afternoon were talking about 4.0 from a technology standpoint and from a people standpoint. And this was probably the most interesting thing that we came across, because you know, I would say in our industry we pretty much all have, and I'm guilty of, or at least I was guilty of it too. We have a very blinkered approach to 4.0 that, you know, it's down at the shop floor level, and it's, you know, communication between machines, it's getting them to talk to each other, it's getting them to pass data along, it's getting some of that data to go to a central control system, which is it is a key part of 4.0. But you know, these guys were going downstream to the quotation stage and linking that all the way through to the system, so that the bill of materials that was quoted pretty much automatically gets ordered, gets delivered at the time that it needs to, goes into all the towers, comes out, goes onto the production line and gets built. You know, the first question was, oh my God, that's going to get rid of everybody. But the answer was no, it's going to give them different stuff to do, because they have to control the data, they have to do some spot checks on what's coming in, and they have to do a general amount of control. And again, we get back to these jobs that don't exist today that are going to be key in the future. And you know, the key things that I take away, and I'm going to check them to make sure that I don't get them wrong. Continuous and connected learning, more engagement at all levels within the factory. Learning becomes part of daily life. Technology is used to simplify the working life. And the real important one is people become key to the company's success, because everybody has the ability for this technology, but the way the technology is implemented, in other words, if the sensors tell you something's going wrong, you still need to have the ability to know what you need to do to go on the line and fix it. And that happening will be the differentiator between, let's say, between production facilities. It doesn't have to be between competing companies. It can be, you know, different facilities of the same company. So, you know, there's actually going to be a need for a higher skill level of people. And the upskilling is to be able to take the data and interpret the data to know what we need to do to fix the line, to get everything back running at full speed, and to get the first pass yield up to where it's expected to be. You know, and the other thing they were talking about was actually, you know, design for manufacturing, design for test, design for X also needs to be rolled into this, because you know, if you're stuck with a bad design, you ain't ever going to make any money out of building it. So you know, the factory for the future, or the factory of the future, becomes one that has a link to the design team who's basically putting the board together. You know,
well, that has been a holy grail for years, hasn't it? To get this design for manufacturing closed loop, because what's happening at the moment is that it starts at one end, it goes through the process, but none of that information circles back to the designer, and he keeps making the same old mistakes. It needs a system that literally takes that information back to the designer and even builds it into his rules based, that he cannot do that, you know, in these circumstances. In other words, it gives him much more guidance with his next iteration of designs. So
yeah, and as we all know, different PCB plants have different capabilities.
Yeah.
Which leads me on to the last thing that actually came out from one of the guys who was talking about when you upgrade your facility, it has to be holistic. You know, his comment was, again, back to bare board manufacture. He said, you know, that the trend at the moment is for everybody to put in a laser drill. They want to put in a laser drill so they can do very small vias, but more importantly, they can do blind vias.
Right.
And of course, the problem then is, if you can make a board with blind vias on, you're expected to do very small holes as via holes. You're expected to do very accurate pads. You're expecting to have more accurate lineup, thinner lines and spaces, and a whole load of other things that go with it. And he said, you know, a lot of people, when they start upgrading, they don't look at the big picture, and they don't wait until they have the budget to do the whole thing.
Right.
Because he said, you know, you put in a laser drill, it costs you a load of money. You don't actually get any of the extra work that you're hoping for, unless you can do all the other things related to that step up in technology that you're trying to make. And
but you know that happens in assembly as well. Yeah. But you know, I mean, in the assembly business, you know, it's long been known that in Asia they replace line. They don't do it in onesies and twosies, which is what we do in the West. You know, typically you'll put a new pick and place machine in, but you won't put a new printer in and a new reflow oven at the same time. You know, you need to look at the whole process.
Yeah. And the guy from Atotech who was speaking in the morning was talking about plug and play delivery. They make equipment, again, for making bare printed circuit boards. And he said, you know, in the past, they'd sell machines. But he said now they sell, you know, a plating line or a something line, and basically the whole thing is commissioned at their site, put in a container, and shipped. So it already works. Everybody knows that it works. Everything that needs to be linked together is linked together. It just needs taking out of the container, dumping on the shop floor, and power and water and waste connected to it, and it's plug and play and ready to go.
Amazing.
Yeah, and you know that obviously they have an advantage because they're selling a whole part. But you know, you could see huge companies like, you know, ASM pretty much. You know, I kind of had this picture in my head of them doing a plug and play line. You tell them the kind of stuff that you're building. You tell them how many you need to build, and they just, you know, deliver all the parts. We plug all the connectors in, and away we go.
Right.
And you know, it's one of those things where when someone's bought it, they don't want 2 months of commissioning before they get it up and running.
Yeah.
You know, they want to know that it's like their TV or whatever. You know, once I've put the plug in, dialed a few bits, then we're off and ready to go. And I think, you know, that's going to spring more into the industry.
Yeah.
And again, vertical integration of the process so that you have, you know, more people doing the same thing. You know, it's like indium still making that whole variety of different materials, because, you know, it helps when you're dealing with people, because you're getting everything that you need, you're getting the latest technology, but you're dealing with a smaller number of contacts. And all of those things take time. They take space on your MRP system or monitor or whatever you're using. And, you know, I think that's going to be a, you know, I hate to say it, you know, a post-COVID realism, but I think that's, you know, it's changed a lot of people's thinking. And these kind of things are going to happen a lot more.
Yeah, no, absolutely it has. I mean, we've seen a couple of examples of it today, you know, with the DuPont acquisition, and of course the Naprotec story. One of the things that definitely you touched on there that has certainly been growing very rapidly over the last year is the sale of these towers. These component towers have been amazingly successful. People have realized that having the components closer to the point of use is absolutely valuable. It helps to maximize machine uptime. And one of the projects that we've been doing recently is shark pull. This is another project that we undertook during COVID. And this is where we put manufacturers of equipment and materials together with EMS companies. And the EMS companies basically reviewed the videos that we made of their equipment, and then gave them real-time, feedback on the equipment, which is very, very valuable to them. And it really turned out to be a win-win. There's a couple of examples I'm going to show you here. The first one is from a company pretty well, Nordson Dage Assure, and a component counter, which we'll show you just a few minutes of their shark pull video to give you a flavor of what it was like.
Counting components is a time-consuming and a people-consuming necessary evil. But in fact, many companies still do not count at all, or they only count what they consider to be important or expensive components. Having the correct material in the correct quantity at the right time and place with cost efficiency is a huge task. Even the most productive companies, the procurement and storing of incoming materials is a daily business, but often lacks the same end-to-end accountability as the rest of the production process. Inventory management is often overlooked and not considered at the same level of urgency as the rest of the production, when in reality, without inventory, there is no production. Even if you've invested in the best pick-and-place machines, the best printer, the best reflow, and the best process engineers, none of that matters if your line stops because you don't have control of your inventory. The issue is simple. You believe there are 350 components on a reel. You need 335 to complete a job, but eventually you discover there were only 320 and the line stops. By the way, it doesn't matter what the cost of that component is, but more relevant is the cost of having a line down. And remember, a component costing 1 penny can stop a line just as easily as a component costing $1,000. Let us share with you a more reliable and highly efficient way to count components, saving you time, resources, and money. The Nordson Dage Assure X-ray component counter is not only about counting components, but actually it's more about improving efficiency by keeping SMT lines running. Let's discuss how you can do that using Assure and its industry-leading standard features.
So there's an example of basically a really good system that has been demonstrated today. That was just a very small part of the video, but the EMS companies evaluated that and gave real feedback to the company, which is very, very useful. And in turn, the EMS companies love the videos because they're not able to go out to trade shows at the moment. They're not allowed to invite salespeople into their factories. So it was a win-win. And in fact, some of the feedback we got was that they actually learned more from the video than they would have done if they'd gone on the booth at a trade show, which is quite exciting.
You actually see the technology working in anger rather than, you know, somebody having an unreal setup with just a couple of reels in it or something. You know, it's
right.
Yeah, it is a huge difference, and it shows the products in a much better light.
Right. I mean, it really got the message over of the use case for component counters, for example. I mean, you know, basically it tracks data and it tells you that if you're a couple of components short, you know, it only takes a few components to mess up an order. You know, this system, you know, lets you know where everything is, what condition it's in, etc. There was a couple of different types of Sharp Pull video we did. We also had some people who presented their own video or certainly presented at the beginning. And here's an example of one that was done for a company called Serio that we've mentioned a couple of times today.
Hello, my name is Christopher Fredrickson, Director of Engineering at Serio. And I'm here today to tell you how you can extend the stencil life of your solder paste, reduce solder paste waste, prevent printing defects, and all in all, get the most out of your solder paste with the Vision Mark 1 device. Have you ever received a jar or cartridge of solder paste that seemed questionable and thought, can I still use that? Maybe it arrived warm, or maybe it's just not printing as expected. Or have you ever experienced printing problems that you just can't get to the bottom of? Getting skips for no apparent reason? Not getting a good roll? We see customers all the time where they get drastically different printing performance between lines or facilities for the same paste. And it can have quite a few different causes. In some cases, we've seen a humidifier directly above one line, causing additional defects. In other cases, the facility might be in a region where humidity in the environment is very difficult to control. But there is always one thing in common in all of these cases. The solder paste itself changes drastically depending on how it's used and handled. The Vision Mark 1 device allows you to measure and control your solder paste before adding it to the printer or during printing to ensure that it is fit for use. Based on fundamental material science and using cutting-edge sensors and machine learning, in minutes, the Vision Mark 1 device can tell you about the underlying chemical phenomenon within the solder paste that drive its viscosity and printing performance.
Okay, so there you go, Keith. There's a couple of examples of videos we've used in the Sharp Pull project this year. It's been very successful. There's actually been some companies sold equipment doing it, and we've been very, you know, it's been quite labor intensive, but it's certainly been worthwhile. But circling back on some of the technologies we looked at there, you say that you were telling me off camera there that there's the towers really do a lot more than just count the components.
Oh yeah, I mean that, you know, people. If you'd have said about either of those two products in the videos 5 years ago, you know, that this is what you were going to use or invent or whatever, people would have kind of looked at you like you were slightly crazy. Yeah. You know, you've got a stores, you know, it's got a storeman, it's got a lock on the door, it's probably got a quarantine area. You know, why the hell do you need anything else? And now people have started to see how they work and how to use them. I mean, you know, if you put an X-ray component counter beside them, then effectively not only do you, let's say, check in your stuff, but when you finished a batch of boards, then you know how many components are left on the reel. They're all stored in a good controlled environment, They're static protected. Basically, they're just kept nice and safe, and you're continually generating the stuff for smart factory, industry 4.0, whatever you want to call it, that's actually data. This is the part number, this is the batch number, this is when, this is when they were made or when they were delivered or whatever. This is how many units we have left. There's a calculation somewhere that says, okay, we've got 500 boards to build. It's got X number of these components on each one. So yeah, we've got enough components. We can actually start setting up the line and we can run this. And, depending on the tower, it pretty much hands the operator the right thing. So
yeah, the digitization and the traceability that it offers is huge, and I'm wondering if many companies have used this really as their first step into the Industry 4.0 factory of the future world, because it does offer so much more visibility of their supply chain.
Oh, it certainly does. And the worst thing historically that we've always had to work out is, okay, customers ordered 10,000 of these, can we build them? And now that's a question you can ask on a PC in a few seconds, probably.
Yeah.
And within the factory where all the things are that you need to pull together to put into a pre-cart, so that you can just stick that cart straight into the pick and place machine. And the system knows the size of the panel and all the rest of it, and you've probably even got stored settings for the reflow oven and all of the other stuff. So yeah, it makes changeover much slicker and much faster. And if I'm talking to people who've been in the industry for more than 10 years, we've all got to a situation where you've loaded a line and suddenly the component that you've got and the reel is the wrong one, and there aren't any of the right one. So you either have to sit there and wait, or you have to strip everything out and reload. So yeah, it's really giving accurate data. And the in situ wear, I mean, I loved that thing from the first time I saw it, because we've said several times today, somewhere between 50 and 70% of your faults are related to the stencil thing. And the variability of solder paste, okay, I mean, it's much better now than it used to be, but I mean, there's still a variability from batch to batch because it's a manufactured process.
Absolutely.
If it falls within the top and bottom of the spec, then it goes out, whether it's up here or it's down here. And that's going to give it different reactions, different time on stencil before it starts causing problems. And to be able to check it so quickly and so easily is brilliant, but also to build up a historical database of that information, which will help you going forwards. So yeah, I mean, you pick two really great things to talk about, and I think they work really well with your shark pool concept, because they are still, for some people, relatively new technology. And that's the stuff that people need to learn about, because it's the resistance to change. And for some people, they probably don't even know it's out there until they see the video or sign up to Shark Pool or whatever they do. And if potential customers are then feeding back to improve the products, then that when you have a system that's in the market, the hardest thing to do is to get that constructive feedback of, oh God, why don't you do this, or why don't you do that? And it's just sounds like it's working as a really good concept, Trevor.
It is a great concept. I mean, and the variability of paste in the manufacturing, any factory is huge. As you say, it's it changes from batch to batch, it changes from factory to factory, and it can even change from line to line, believe it or not. I mean, the temperature and humidity are critical to the performance of it, and it only takes someone to turn on an air conditioning system somewhere in the factory, and it can change the dynamic instantly.
Yeah. I mean, the favorite trick that I used to see in Asia was opening all the windows.
Yeah, exactly.
Yeah.
So having a handheld device that can instantly measure the suitability of that paste before you put it on the stencil is absolutely huge. It really is. So anyway, Keith, we're coming close to the end of our program today. I want to, first of all, thank you for joining and helping me with this. It's been fantastic. What do you think about this process that we've gone through today? You know, this platform where we're trying to do live programming and trying to bring a flavor of Apex and some of the companies that are involved in it and the suppliers of equipment. I mean, do you think this is a platform that has been useful and will continue once we get back to normal?
Well, I think there's definitely a space for it, but you know, I have to say, Trevor, I'd rather have been sat at the show doing the Keith Bryant show with you. But you know, we have to accept that that isn't going to happen, at least for a while.
Right.
But no, I think, you know, that this way of giving people a short burst of some of the information, and you know, the stuff that we've talked about with IPC, I guess it's going to go out virtually at some stage. So you know, if they want to see more about what the ladies from Department of Defense contractors were talking about, then you know, they can go and look at it. So yeah, I think it works very well as a sampler, and also giving, you know, key takeaways to people.
Right. Yeah. No, I think all the Apex content from Apex the conference will be available for the next 30 days, I believe. First of all, so you will be able to see that. All the content from this show and from the show we produce over the next 2 days will be available to watch. Hopefully, within the next 24 hours, we'll be able to watch this show on the Global SMT website. But there you go. So I think
I was just going to say, you know, it's really good with all these platforms. And you know, the thing that I would say about Apex this year is that the speakers that I've listened to have all been topical, interesting, and non-commercial. And as you've probably gathered from my enthusiasm today, there's been good stuff to take away. And, you know, if I'm 30 years in the industry and somebody can teach me new stuff, then, you know, it's got to be a good gig.
Yeah, there's so much going on at the moment, Keith. It's hard to keep up with it, to be honest. You know, the industry is changing in so many areas. It's unbelievable. But that's exciting, as you say, and it's great to be part of it. So I want to once again thank you for taking part today. Tomorrow, my guest will be your good friend, Mr. Mike Conrad from Reliability Matters. So we look forward to inviting him on the show. And until then, I want to thank our audience for watching, and we hope to see you again tomorrow or sometime soon.
Yeah, and thank you, Trevor, and thank you, Summer, behind the scenes, keeping it all held together. So yeah, it's been my pleasure and a joy to speak to you. I'm sure you'll enjoy listening to Mike Conrad tomorrow and Michael Ford the day after. So I'm going to be listening too.
Good.